Hey everybody, we're going to be doing 12.3. Hopefully today we won't be interrupted by some random Star Wars or bells or whatever has happened in these videos, but whatever happens, we're just going to keep on rolling. So we're talking about sectors and segments of circles. Again, we're going to have to define these two things, make sure we understand what those pieces are, and we're of course going to have some formulas to find out those areas of those sectors and segments of circles. First off, we're going to be in page, I'm going to try to show you where we are on the book, so have your book handy with you. We're going to be in page 936, and concentric circles are circles that share the same center point. If you've ever seen where you have a water droplet, and they do it in slow motion, where one little water droplet drops into water, and you see the rings that happen. Every one of those circles has the same center. The center is where the drop of water hit the actual water, and then those rings that form out are called concentric circles. So right here on this dartboard, in the book they do a couple of things that are different, so I'm going to give my own answer to you guys. They actually have 6, I think there's 6 or however many we get, they have one less than us. So here we go. They're going to ask, how many concentric circles do you see on the dartboard, not including, so it says not including the dartboard itself. So that means not including this outside ring. So if we do this, actually, I think we're going to get spot on to what they have. 1, 2, 3, 4, 5, and then I think they even included this one. 6. So we can have 6. Okay, hopefully you see those. In the center, remember, a center is going to be like the smallest little tiny point, not the actual whole center of that. So the outside ring of the bullseye would be one of the concentric circles. So those are all concentric circles. They said not including this one out here. They're not including that one. So page 937. The diameter of the outermost circle is 170. Remember, diameter goes from one side of the circle all the way to the other side through the center. Okay? So calculate its area. Express it in terms of pi. So if we were going to do this, area, if we recall, this is old, area equals pi r squared. They did not give us the radius. This is a diameter, but that's okay, because I can just take 170 divided by 2, and that gets me to my 85, which is the radius. Remember, radius is half. It's only from here over. It's half of the diameter. So that's where this 85 came from. They throw it in there, you square it. They left it, it says express it in terms of pi, means you do not multiply by pi. The answer would be 7,225 pi. Okay, so you leave that pi there. If they ask you to round it to the nearest 10th or 100th or whatever, then you would put in your calculator 7,225 times 3.14, and then you would round that answer at the end. But if they say leave in terms of pi, this is your answer right here. All right, now we are on, keep going down in your book, and you'll see it says a sector of a circle is a region of the circle bounded by 2 radii and the included arcs. So if we were talking about the sector, right here they labeled it for you. This would be a sector, kind of like a piece of pie. Yes, leave it to Mr. Martin to talk about something fatty. All right, so determine the number of sectors in the outermost. So here's what I do. I went right here and I drew this across, which if you notice, I created a diameter when I did that, and I counted how many were on this side. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 on this half. That means there's going to be 10 on this half, for a total of 20 sectors. Now, it says, determine the measure of the central angle. and the measure of the intercepted arc formed by each sector. Well, we know that the central angle is going to be divided up. So we are dividing this. A full circle is 360 degrees. That's a pretty darn good circle. I'm proud of myself. And we are dividing that up 20 times, which I'm not going to have 20 in there. But they're going to be evenly 20. So I'm dividing that by 20. And that's how they got the 18 degrees. And we know that since that's a central angle, the arc is also going to be exactly the same. So it's going to also be 18. Determine the ratio of the lengths of the intercepted arc and their circumference. Well, that's what we did in that last section. The ratio was, we have an 18 over 360, which when you reduce that, it's going to turn into 1/20th. Remember how you reduce fractions? I know that 3 is going to go into both of these. 3 is going to go into 18 6 times. And this 3 is going to go into it 120 times. 6 goes into 120. 6 goes into 6 one time. 6 goes into 120 20 times. That's how we reduce it to 1/20th. So that would be, it's going to be 1/20th the circumference. Determine the ratio of the area of the sector. The area is still going to be 100 and it's going to be 1/20th of it. So determine the area contained in each sector. Well, we just figured out in the previous problem, there's 170 across, so we know that this is the area right here of the full thing. Well, the area of one of the sector is only going to be 1/20th of that. So what we did is we took 1/20th and times it by the actual area and came up with this answer. That will be the area of each section. To determine the area of the sector of the circle, I multiplied the fraction. So they're just telling you what they did. They just multiplied that fraction by the total area. And you're going to get some more practice on this in class tomorrow. So please make sure that you understand this. This is the fraction of, this is the fraction that we found by taking that central angle. Alright, formulas for determining the area of a sector. Please understand we're talking about area of a sector. Sector, if you were thinking, is like the piece of pie. It would be this whole thing, because they're going to talk about another part in just a second. We need to know the difference between the two. So it is area of the circle times the measure of the angle divided by 360. That right there is, again, the ratio. It's like how much of it. You know, this is 1/20th of the whole thing. Then all you do is figure out the whole thing, the area of it, and just take a 20th of it, and that'll be this part right here. Just like if you had this, and this is 1/4 of it, right? So if this is 1/4, and this whole thing is 100 meters squared is the whole area of this, and I want only 1/4 of that, it's going to be 25 meters squared, right? I just divided that by 4, times it by 1/4. That's because I have that ratio when I know that that's 90. All right? All right, now we have totally switched gears. That is everything for sector. We are going to mix these up in just a minute, but we need to know the difference. We are now switching gears, and we are talking about a segment. A segment is the region of a circle bounded by a chord, which we know a chord starts on the circle and ends on the circle. It goes across, and the included arc. So we are talking about this grayed area. Again, I'm in your book somewhere. You can find that. So here we go. Name the chord and the arc that bound the shaded part of the circle. The chord is A to B. And notice when I name a chord, it is a line segment. It's a piece. When I talk about the arc, it's going to be, again, AB, but this time I put this. There's a lot of you who made that mistake on this last test. You did not care about the symbols. Some of you didn't put them. Some of you mixed them up. You've got to start being more specific, because if you put, for a chord, if you put arc AB, that is wrong. Okay? If that is supposed to be talking about a segment, you have to have this in it. If we're talking about an arc, you have to have this symbol, and you cannot have the line segment symbol. So please, pay attention to those details. All right? Describe the method to calculate the area of this. So one method for calculating the area of the segment would be to calculate the difference between the area of the sector and the area the triangle forms. So here's what that is saying. You've got a circle. You've got this, this is the sector. Here we have the segment. If you see this triangle is being formed, okay, I'm going to redraw this circle up here. If I take the area of this whole thing, which is the area of the sector, and I subtract the area of the triangle, I take this area, I will be left with this area right here. Okay, so that's what they're saying. Find the area of this whole sector, find the area of the triangle, take these two, and subtract them, and you are left with this right here. Hopefully that makes sense. All right. If the length of a radius of a circle is 8 centimeters and the measure of ACB is 90, use your method to determine the area of the shaded segment of the circle. Express your answer in terms of pi. That means we are going to leave. We are going to leave pi. Then rewrite your answer rounded with the nearest tenth. So we're going to do it to both of them. So right here, the area of the sector. How do I know the area of the sector? Again, you take the 90 and put it over 360. That is our ratio we've been referring to. Times it by, to find the area of a circle, remember area equals pi r squared. What was my r in this case? 8. So they took 8 and squared it, times it by pi. 8 squared is 64, so this is just turning into that. They're just showing you their steps. So they took 8 and squared it, that became 64 pi. They reduced this to 1/4. 1/4 times, that is 16 pi. Hold on one second. All right, then you take the area of the triangle. The area of the triangle is half the base times the height. They found the area. If I know that this triangle, if my radius is, my radii, this is 8, that's going to be a base. That's going to be the height. Remember, it's base times height, so it's going to be 8 times 8. That's where they got that from. Take half it, that's where they got the 32. 16 pi was the area of the sector, and they subtract the area of the triangle, and that is my exact answer. They then took the 16 pi, put that in the calculator, and then they subtracted 32, and that's where they got the rounded answer from. All right. This one, I want to change this problem. It's in your book. This should say area of the sector, and this should not say this. And if I want to find the radius by doing this, then I can follow these steps. I have the area of the sector is equal to the ratio times the area. But notice in this one, I am trying to find the radius. So what I'm able to do is plug in all the information I know. That's the area of the sector, which I changed the wording up there. I used my 90 degrees because I know that it's 90 from this picture, and I know that this is the arc is going to be 90 also. That's 90 out of 360. So I can reduce that to 1/4, and it's pi times r squared. There's my r, right? And that's what I'm actually trying to find. That's my question mark. So then I times by 4 on both sides, times by 4 on both sides. That canceled out. That made the 9 become a 36. Well, where'd the pi go? Well, I have to divide by pi over here, which they didn't show. Divide by pi. The pi is gone. I'm only left with a 36. Square root both sides, and then you get r equals 6. All right, and then this one right here is our last problem, probably the best one. If I wanted to find the area of the segment, and they tell me it's this, and they want me to find the radius, remember the area of the segment is the area of the sector, the whole thing, minus the area of the triangle. So I'm taking this area and I'm subtracting that area. Well, that's what they did over here. This right here represents the area of the sector. This represents the area of the triangle. Well, when you do this, you don't have r's, so you can't fill them out. But you can simplify as much as you can. And so this becomes 1/4 times pi r squared. This becomes, all they did is they said r times r becomes r squared. Well, once you have an r squared here and you have an r squared here, this is from algebra. It's called factoring because they both have an r squared. I can pull the r squared out, and then I'm left with 1/4 pi minus a half. They then take a calculator and make that become that. They just put 1/4 pi, so pi, and then they 3.14 times or divided by 4, get an answer, minus 0.5, and then you get this. Now I'm left with r squared equals, or r squared times this equals this. I then divide by 0.285, divide by 0.285, and then they get that around 36. You square root both sides, and you get r equals 6 again. 6 just seems to be a common answer. I hope you guys enjoyed that. If you have some questions, make sure you see me in class tomorrow. I'll go through it a little bit slower with you. Hopefully you can follow what the book is already put in there. You can pause the video and kind of chew on that a little bit. I will see you tomorrow in class, and then this is the end of chapter 12.